Today we'll be starting our three-part segment on instrumentation, specifically the internal mechanics and the details of how the six-pack functions. We'll be looking at three different major systems that oversee these instruments, each instrument being categorized by which system it belongs to. There's the vacuum system, the electrical system, and the pitot system. For this video, we're going to break it up and only focus on the vacuum and the electrical system instruments. We'll start with the vacuum system. Certain instruments are powered by what are called gyroscopes. A gyroscope is a device that uses a rapidly spinning wheel to maintain a stable reference direction in space. The more the wheel spins, the more resistance it has to forces that may try to tilt it or disturb its stability. You know those fancy gimbals on drones? Even with the object they're attached to being moved around like crazy, the gimbal stays still, and that's how the camera captures such stable video. Well, gyroscopes also use gimbals and work the same way. This principle is referred to as rigidity in space and is an important concept when considering gyros. There are two instruments powered by the vacuum system, and both of these use gyroscopes. These are the attitude indicator and the heading indicator. The vacuum system spins the gyros in these instruments using engine-driven vacuum suction. Here's how it works. The airplane contains a vacuum pump that sucks outside air into the plane. This air then passes through a filter to prevent debris from entering the system, where it is then fed to the attitude indicator and the heading indicator's gyros. You've probably seen water wheels that catch water as the blades or buckets move through it. Well, there are notches on the edge of the gyro that catch air the same way. The gyros catch the air to spin, and this is how the instruments are powered. If the vacuum pump were to fail, these instruments will become unreliable and you may lose altitude and heading reference, which would not be a good thing. So how would you know if you're losing suction? Well, there's a small yet important instrument that we haven't covered yet, and that's the suction gauge. The suction gauge indicates how much vacuum pressure, or suction, is being produced by the vacuum system. It tells you whether the gyroscopic instruments are getting enough suction to operate properly. Now, the suction is measured in inches of mercury, and most vacuum-powered instruments work with 4.5 to 5.5 inches of mercury, which is this little green range here. It's important that the needle stays in this range, so be sure to check the gauge to confirm there's enough suction. A low amount of suction can cause the gyros to spin too slowly, making the instruments unreliable, and a high amount of suction can seriously damage the instruments. And if there's zero suction, this means the vacuum pump has failed completely, at which point the instruments will too. Definitely double check the vacuum system is working properly before takeoff. An airplane's electrical system powers several components, including lights, radios and avionics, the auxiliary fuel pump, and more. But as far as the instrumentation is concerned, it only powers two in most training aircraft, and those are the fuel gauges and the turn coordinator. Now, the turn coordinator also operates using a gyroscope like the two vacuum instruments, but instead of being powered by the vacuum system, it's powered electrically. It runs off the aircraft's 14 or 28 volt system, usually via a bus powered by the alternator. This electricity is fed to the turn coordinator's gyroscope, spinning the wheel and powering the instrument. The readings are indicated on the instrument's inclinometer, where it measures the aircraft's rate of turn and whether or not it is coordinated. A standard rate turn is defined as a turn of 3 degrees per second. If the vacuum instruments fail, the turn coordinator will act as an alternate way to tell if the wings are level. If the electrical system fails, the turn coordinator will too. That will only be one of your problems at that point though. Okay, we'll keep this one short today. You don't necessarily need to know each and every part that comes together for each of these instruments to work, but having a good idea of how these systems function will help you out a ton, and much of it is mandatory knowledge for your private pilot exams. In the next one, we'll go over the pitot system, as well as solutions to some mechanical problems you could run into up in the air. Whether you're using these videos to learn and study to become a pilot, or you're just curious about aviation, I'm glad you're here, and thank you for watching. Once I release part 2 to this, I will put the link in the description. I'll see you then. Thanks, guys.